Alright, so let's say you're given the situation of a mass falling from a height. The question says a box is dropped from a height of 6 meters. If it feels a force of 5 newtons due to air resistance, use the work energy theorem to find the speed when it hits the ground. So we start off by drawing a free body diagram for this mass. Start off by drawing our mass here, and then we can draw the weight force bringing it down, and we can draw the force of air resistance equal to 5 newtons. And then we can also draw our initial and final position here, label it y1 and y2, and we know that y1 is going to be equal to 5 meters. Since the question says it's dropped from this height, then delta y is going to be the displacement between them. We need the speed at y2 using the work energy theorem, which can be written in these forms here, where v2 is the velocity at the bottom and then v1 is going to be the velocity at the start. Note that k represents the kinetic energy. So we have two unknowns. We have the work and we have the velocity v2. So we can use our second definition for work, which is given here, where F is the net force and delta x is the displacement. But what's the net force in our situation? So we have the air and we have the weight, but we're going to define positive as down since the object is moving in the downward direction. It's going to be weight minus force air resistance. Plug in weight equal to mg and air resistance equal to 5 newtons. We get this expression. We can replace mg by their values, and then we multiply the amplitudes in units with the term on the left, then do a simple subtraction to get this for the summation of Fy. This represents the net force on the object, and we can apply it back to our equation here. We have our force, and then we have delta x equal to the displacement. So in our situation, we have these 2 points, y2 and y1. Delta y is going to be equal to y1 minus y2. If we plug in our values here, we get this for the displacement, so we can plug that in. Do a simple multiplication, multiply the units and the amplitudes, and we get this. It's going to be the work to move the object from y1 to y2. And so we can use the solve for v2 by plugging it back into this equation here. Plug in the work we just found, noting that velocity 1 is going to be equal to 0 since it starts at rest. And we know that mass is equal to 2 kgs. We plug that in. The 2's cancel out, just leaving us with 1 kilograms on the right term. And then we can multiply both terms by 1 over 1 kilogram. Obviously, the amplitude 73 divided by 1 is still 73, but for the units, we know that joules are equal to newtons per meter, so we can convert it and then do some simple cancellations, and we get this for the unit analysis. If we take the square root of both sides, we get this for the final answer. So this can be the velocity when the mass hits the ground. And this makes sense because if we look at our diagram here, we have the mass falling down and we have work being 73 joules, and it's positive, so it's working in the same direction as displacement, which this positive work being applied causes the object to increase speed. So this final answer makes sense.